welcome to this class. I am Mubani Kirsten, and I'll be taking you on the subject chemistry. The theme of our class is chemistry and environment, and our topic is hydrogen, part 2. In our previous class on hydrogen, part 1, we talked about what hydrogen is, its oxidation number, electronic configuration, its chemical and physical properties. For our class today, we'll be looking at the laboratory and industrial preparation of hydrogen and its uses. So at the end of the lesson, you'll be able to describe the laboratory preparation of hydrogen. You should also be able to describe the industrial preparation of hydrogen. Then you should be able to state the uses of hydrogen. Now, laboratory preparation of hydrogen. There are 3 main methods available for preparing hydrogen in the laboratory. They are the action of an acid on zinc, the action of cold water on sodium, and the action of steam on iron. We'll take a quick look at each of these. Now, the action of an acid on zinc. Acids such as dilute hydrochloric acid or tetrasulfate 6 acid is used for this purpose. This acid is added to a flat-bottomed flask, such as we have here, that contains metallic zinc. Magnesium can as well be used in place of zinc for this reaction. Okay, so when this acid, hydrochloric acid or tetrasulfate 6 acid, is added to a flat-bottomed flask holding a metallic zinc or magnesium, as we can see here. Now, if the zinc is pure, we can add a few drops of copper 2 tetrasulfate 6 solution to act as a catalyst, that is, to speed up the reaction. Now, what happens is that the acid which was introduced or added to the zinc attacks it with the liberation of hydrogen gas. So when this happens, what happens is that hydrogen gas is formed. Now, this hydrogen gas that is liberated or given off is collected in a gas jar over water. This method does not require heating. It is just the reaction of the acid and the metal that gives hydrogen gas, which is collected over water. So the reaction would go this way: zinc plus hydrochloric acid, which will give us zinc chloride with liberation of hydrogen gas. Or, remember we say we can use magnesium in the place of zinc. If we use magnesium with, say, tetrasulfate 6 acid, we can also have the liberation of hydrogen gas from this reaction. Now, action of cold water on sodium. To do this, what we'll do is you fill a trowel with water. This is a trowel, a water trowel. You have filled a trowel with cold water that has been colored red with litmus. So the water in this trowel is red because of the coloring in it. It has been colored red with litmus. Now, the next thing you do is wrap a small piece of sodium loosely, okay, in a piece of wire gauze. Now, we do this so that the sodium can easily drop to the bottom of the trowel. So what happens is that the sodium here, as you can see, will easily react with this cold water to give off hydrogen gas. As you can see, these bubbles here are hydrogen gas. Next we do is, to be able to collect the hydrogen gas given up, okay, we'll fill a test tube with water and invert it, that is, turn it over, okay? Invert it over the piece of sodium, just as we have in this diagram. This is a test tube that's inverted. So we invert it over the piece of sodium in the trowel so as to collect this hydrogen gas formed, okay? And the reaction goes this way: sodium plus water to give us sodium hydroxide with the liberation of hydrogen gas. But this reaction is naturally vigorous. It's very fast. It is quick. So care must be taken when carrying out the reaction. Next is the action of steam on iron. Now, to carry out this preparation of hydrogen, what we'll do is we'll partly fill a combustion tube with some iron filings and set up the apparatus as shown here. So this is a combustion tube, and inside we have iron filings. Now, the next thing is that we have to apply heat on this combustion tube in order to heat up the iron filings till they are red hot. The next thing we do is to generate steam by boiling the water in the flask. This is a flask filled with water. So we heat this water to be able to generate steam or gaseous water. Now, next we do is to pass the steam over the red hot filings. So this steam is passed over the red hot filings through this tube. So the steam goes through this tube to the red hot filings. What happens when steam passes over the red hot filings is that hydrogen gas is given off. So as the hydrogen gas is given off, the hydrogen gas formed is collected over water. So this is a water trial, and here we see that the hydrogen gas can be collected. This reaction is actually a reversible reaction, and the equation is we have iron here plus steam, which will give us iron oxide and hydrogen. So this chemical reaction is actually used in the laboratory to prepare hydrogen. Now we'll be looking at the industrial preparation of hydrogen. Industrially, hydrogen can be prepared from water and from natural gas. From water, we can prepare hydrogen from water gas, or from electrolysis of water, or from electrolysis of brine. And from natural gas, we can prepare hydrogen with natural gas and steam, or by the thermal decomposition of natural gas. But for the sake of our class today, we'll be looking at how we prepare hydrogen from water gas and from brine. And then we'll also look at how we prepare it from natural gas and steam. Now, preparation of hydrogen from water gas. This method is what we call the Bosch process. Now, cheap raw materials such as water and coke are used. So what happens is that steam, which is water, gaseous water, is passed over red hot coke at a temperature of 1,200 degrees Celsius. Now, when this happens, a mixture of carbon monoxide and hydrogen, otherwise known as water gas, is formed. So this reaction makes up the first process. We have coke and steam, water, at a temperature of 1,200 degrees Celsius, forms what we call water gas. Next step, excess steam is mixed with the water gas produced and passed over a catalyst such as iron 3 oxide or chromium 3 oxide at a temperature of about 450 degrees Celsius. So this is the water gas produced. Remember that our first reaction is this. We say that coke is passed over steam at a temperature of 1,200 degrees Celsius to produce water gas. And the second reaction is that excess steam is mixed with the water gas produced. This is the excess steam, which is mixed with the water gas produced over a catalyst such as iron 3 oxide or chromium 3 oxide at a temperature of 450 degrees Celsius. After this, the carbon monoxide in the water gas is converted to carbon dioxide and more hydrogen. So this carbon monoxide in the water gas, when it is mixed with excess steam at this temperature and with this catalyst, produces carbon dioxide and hydrogen. This mixture is then passed through water at a pressure of 30 degrees Celsius. The carbon dioxide produced is absorbed in the water because obviously carbon dioxide dissolves in water. So it is absorbed in the water, while the hydrogen gas, which is insoluble in water, is collected as such. Now, the first reaction, which is the reaction of steam and coke, is endothermic. This means that the reaction actually absorbs heat when it takes place. While the second reaction is what? Exothermic. This means that this second reaction, which was the reaction of water, gas, and excess steam to produce carbon dioxide and hydrogen, this reaction actually gives off heat when it takes place. So the overall process is known as the Birch process. Now we'll be looking at the preparation of hydrogen from electrolysis of brine. We say that very pure hydrogen is obtained as a byproduct in the electrolysis of brine for the production of sodium hydroxide and chlorine. So during electrolysis of brine for the production of sodium hydroxide and chlorine, hydrogen gas is actually given off as a byproduct. And that is just one of the ways that we can produce hydrogen gas industrially. So the overall reaction is this. We have water reacting with sodium chloride to give us sodium hydroxide, chlorine, and hydrogen gas. Now, we'll be looking at the preparation of hydrogen from natural gas and steam. And we can make use of natural gas such as methane to produce hydrogen because methane is quite cheap. So this method is economically friendly. So what happens is that methane, which is CH4, is mixed with steam, water, then passed over a nickel catalyst at about 800 degrees Celsius. Now, a mixture of carbon monoxide and hydrogen is produced. So this is the overall reaction. We have methane plus water. When passed over nickel catalyst at 800 degrees Celsius, we yield carbon monoxide and hydrogen gas. So that is about the laboratory and industrial preparation of hydrogen. Now we'll be looking at some of the uses of hydrogen. Why is it important for us to be able to obtain hydrogen through different methods and from different compounds? Because hydrogen is of high importance. We'll look at some of the uses. Hydrogen is used in making atomic hydrogen flames. It is used in the industrial manufacture of ammonia, hydrochloric acid, methanol, and some other compounds. It is used in the manufacture of rocket fuel and in welding. Hydrogen is used in the hydrogenation of fats, which are used as margarine or as lard substitutes, and in the manufacture of soaps and candles. Lard here is actually fat from a pig's abdomen. Hydrogen is used in filling balloons as it is much lighter than air. Hydrogen serves as a radioactive agent for making luminous paints. So it means that hydrogen can be used in making of paints. Well, we've come to the end of our lesson today, so we'll take a quick summary. We say that hydrogen can be prepared in the laboratory from the action of an acid on zinc, action of cold water on sodium, and action of steam on iron. We also say that hydrogen can be prepared from water and from natural gas. Then we mentioned some uses of hydrogen, say that it can be used in making atomic hydrogen flames, filling balloons, etc. We'll take a quick test. Which of the following is a method of preparing hydrogen industrially? A, electrolysis of brine. B, the action of an acid on zinc. C, the action of steam on iron. Well, if your answer was A, you're correct. Remember that we mentioned that one of the ways hydrogen is prepared industrially is by the electrolysis of brine. With this, we have come to the end of our lesson today. Thank you for staying with me. With me. With me. With me. With me. With me.